Hello, good morning and good afternoon, according to your time zone. Welcome to the conference. We are about to start in 4 minutes. So, welcome again. Please check your availability to share your screen. So, when you need to just testing for now before we start.
Good afternoon, everyone. Good afternoon, everyone, and welcome to the eighth edition of the IEEE GCAIoT conference. We are so glad to have you today. We are so glad to have you virtually as well. So welcome to everyone. And we would like to start today our virtual session. Again, our official opening will be tomorrow, but today we have the virtual session. So we would like to start our virtual session, and our session is about AI and IoT from theory to practice. The first paper we have is GCAIoT, a cybersecurity assessment framework for IoT devices. And the author is Muhammad Hussein from NTRA Egypt. And Muhammad, you have the hand to start now.
Okay, Assalamu alaikum. Can everyone hear me?
Give us 1 second to fix the audience.
Yeah, sure.
Okay, Muhammad, can you please speak?
Okay, can you hear me now?
1 second, we don't hear you yet. So, can we do another test, Muhammad?
Hello?
Now we can hear
It's a little bit loud.
مثلا سيبه مفهوم.
You may please start.
Okay. So, Assalamu alaikum. Hello and welcome. My name is Muhammad Salah, and I will be with you to present the Cybersecurity Assessment Framework for IoT devices, GCAIoT. This is a novel framework to perform a hardware testing, a hardware security assessment on IoT devices. Actually, this work is sponsored by the National Telecommunication Regulation Authority, and it is a part of a research studies conducted by Egyptian CERT, the Egyptian Computer Emergency Readiness Team. Okay. So the Internet of Things, or IoT, is now a major part of many industries like healthcare, industrial automation, critical infrastructure, and smart cities. As IoT technology grows quickly, it brings a new security challenges, especially with the hardware and devices communication. One big problem is that we don't have a strong framework for testing the security of the IoT. Most of the focus in the research so far has been on the software and network, leaving some important hardware security issues unaddressed. So, as IoT kept expanding, it's essential that we develop a better way to assess and secure the hardware of the devices. This will help make IoT more secure and more safe, reliable, and protected from cyber threats. So if we have an IoT system, in the IoT system, the architecture is usually divided into three main layers: the application layer, the network layer, and the perception layer. The perception layer is where the IoT devices themselves are located. These devices can be thought as an embedded systems, meaning that have the firmware and hardware components. Each of these components, firmware and hardware, has its own areas that can be vulnerable to an attacks, known as attack surfaces. Firmware, for instance, can be targeted through bugs in the code, while hardware might be vulnerable to physical tampering. So understanding these layers and specific vulnerabilities in each component is the key to secure IoT system for potential threats. Okay, this table illustrates some of the attack surface commonly exposed in IoT devices, along with the vulnerabilities and the attack methods that attacker can utilize to compromise the system. For example, hardware attack surfaces can be open, unsecured JTAG debugging port, an unencrypted SPI channel between the system components. This can lead to firmware extraction or unauthorized access to critical security components. The processors and microcontrollers can be vulnerable to fault injection or arbitrary code execution. Memory could be left in clear text, leading to data theft. Sensors and actuators can suffer from physical tampering. PCB can be microprobed for sniffing, or it can be reverse engineered. Cryptographic modules can be misconfigured, leading to key extraction or cryptographic bypass. To address all of these issues, the cybersecurity assessment framework is introduced. The framework can be a smart automated successor for logic analyzers, debuggers, memory readers, and other components that can be used in the process of assessing the IoT devices. So we need a cybersecurity framework for IoT that can automate security evaluations. This framework would assess vulnerability across hardware and software, then generate a detailed report with recommendation for improving security. Automation would make this process faster and more consistent, helping organizations secure their IoT devices more efficiently. Okay, the framework is built around three main components: a PC, a Xilinx Zinc 7000 system on chip, and the device under test or DUT. The PC serves as the user interface and control station, communicating wirelessly with the Zinc 7000 SoC. The Zinc SoC is a core of the assessment system, combining a processing system with programmable logic, allowing it to perform various attack scenarios requested by the users. It configures its programmable logic to implement a specific attack or analysis technique. And finally, the device under test is the hardware devices we are testing for vulnerability. And by connecting directly to the device under test, the Zinc SoC can carry out an attack or sniff data or to provide a robust evaluation of the device security. The framework offers three different connection modes to interact with the device under test, each designed for specific security assessment. The first is the message sniffing mode, or the T mode, which allows us to copy messages and pass between component that messages pass through component without intercepting or altering them. This is useful for passive monitoring. Next is the message injection mode, or the I mode. Here, the device can inject custom message to specific chip or perform a fuzzing test. This shall help us to see how the system responds to unexpected inputs. Finally, we have the message intercept mode, or the U mode. In this mode, the device acts as a man in the middle, giving us the ability to delay or block or bypass message under certain condition. And this can help to simulate an attack that disrupt the communication. Each of these modes provide a unique insights into the security resilience of the tested device. So the GCAIoT framework has three main components: the cybersecurity assessment core, the processing system unit, or the PSU, and the programmable logic unit. The cybersecurity assessment core is hosted on the PC. It provides the user interface, manage attack planning, exchange data with processing system, and generate assessment reports. The processing system unit, or PSU, is part of the Zinc 7000 SoC. It runs a Linux OS, executes the attack scenarios, configures the programmable logic, and collects data to send it back to the assessment core. Finally, the programmable logic unit is an FPGA within the Zinc SoC. It implements a custom logic needs for pen testing, allowing us to create and extend modules for various attack types and analysis. So as shown in the figure, cybersecurity assessment core communicates with the processing system through a wireless channel. This helps us to prevent the problem of ground looping between testing equipment and the device under test. Also, the programmable logic unit have two types of module, which is illustrated in the bottom. It have two types of modules: an attack module responsible for active attack or injecting message and injecting voltage in case of fault injection. and a system analysis module that is passively monitor the device under test behavior during and after attacking. Each module in the programmable logic unit is written in VHDL or a hardware description language, and each have a dedicated device driver that is installed in Linux OS to communicate with the with the module logic. So the following slides show a sample process in the framework. We will look at a UART detection and sniffing attack. This is an example of how the framework actually works. This involves capturing and analyzing UART messages from the device. So the process starts when the user selects the auto-sniff option. This triggers the attack planning procedure in the assessment core, which analyze the request and generates a list of necessary attacks known as attack plan. In this case, the attack plan includes bitwise stream sniffing to capture the individual bits, as well as the UART message-based sniffing to capture the whole messages. Then the assessment core begins by generating the attack stack. The attack stack is a stack of attacks, a stack of files, a stack of files that communicate to each other. The attack stack in this case is the bitwise streaming attack. This attack consists of three parts. A bitstream files containing the logic circuit details to be written to the FPGA, the device driver files, which allows the communication with the programmable logic unit, and the updated binary tree for the device to match and identify the register's addresses. Once the stack is created, it transmitted to the processing unit. The processing unit then writes the bit stream to the BLU, installs the device drivers, and updates the device binary tree. After ensuring that all components are correctly configured, the attack loop is started with the start attack function. This loop performs a bitwise sniffing across all channels for a set duration, T seconds. The sniff data is stored in the memory, and the assessment core retrieves and analyzes it for vulnerabilities. The analysis is carried out using two main functions: channel aggregation and identification, and a protocol configuration extraction function. The channel aggregation and identification function group related channels based on timing of bit changes, identifying channels that show behavioral correlation. The protocol configuration extraction function then analyzes this channel to determine the communication protocol being used, which in this case is the UART, and extracts key configuration details such as UART baud rate. These configuration details are then sent back to the stack generator, which updates the PLU to configure it for the UART message-based sniffing attack, which is the second attack in the attack stack we mentioned before. The process of generating the stack, writing it, and installing the stack, starting the attack loop, and returning the result to the assessment core is repeated for the second attack also. Once the sniffing is completed, the assessment core analyzes the captured message to identify any potential vulnerabilities within the targeted communication protocol or the device logic. So, what is the key features for the framework? This framework offers several key features and advantages that enhance the flexibility and efficiency of the testing process. First, Flexible connection allow all channels to be configured for any protocol, meaning that there is no need for dedicated wires for specific protocols. This flexibility simplifies the setup and saves time during testing. The framework also supports parallel processing thanks to the FPGA-based solution. This allows multiple attack processes to run simultaneously. For example, during a fault injection attack, one block can monitor the system response while another can inject a voltage fault, improving the effectiveness and the speed of testing. Another advantage is the modularity. The framework is designed to be modular, which means users can easily add or configure new attack scenarios and their corresponding attack stack, making it adaptable to different testing needs. Finally, the frameworks enable more hardware security assessment, remote hardware security assessment, because it's operate over a network. Users can connect the testing devices channels can be connected once and configured them remotely for any mode. This eliminates the need to physical desolder and resolder wire on site, saving time and effort. So these features together make the framework more versatile, efficient, and user-friendly for performing security assessment on IoT devices. This image shows configurable templates of VHDL attacks that injects IORT and SPI messages. And the next one shows the software used by the user, which uses an interface that can edit VHDL code. In this step, the user synthesizes the VHDL and generates the attack stack. And here, where the bit sniffing is done over all channels. So in conclusion, the work presented introduce a cybersecurity assessment framework which specially targets the often overlooked perception layer with a focus on hardware security and communication protocols. This framework evaluates the security of IoT device through automated penetration testing attacks, covering a wide range of attack vectors. It then generates a comprehensive cybersecurity assessment report that highlights the vulnerabilities and suggests possible mitigation strategies. Through practical evaluation, the framework has proven effective in detecting and analyzing a broad spectrum of hardware-related cybersecurity threats, contributing to the development of more secure IoT ecosystems. So, looking ahead, we plan to expand the range of attacks and evaluation technique for more comprehensive analysis, broaden the assessment to cover wider attack surfaces, explore the use of machine learning and AI to enhance threat detection, and extend compatibility to support additional microcontroller architectures, incorporate software debugging analysis to uncover other potential vulnerabilities. This improvement will enhance the framework's effectiveness and adaptability in assessing IoT devices. Thank you for your time. I appreciate the opportunity to speak to you.
Thank you, Muhammad, for the interesting presentation. And I would like to ask the audience if anyone has a question, whether virtual or here in the room. If you have a question, please let us know so we can give you the mic so you can ask the question. Any questions? With that said, let's thank the speaker. Thank you, Muhammad. Can you please Thanks, speaker. Our second presenter is Samar Noor from Badr University in Egypt, and the title is AI-driven anomaly detection framework for improving IoT system reliability. Samar, you have the hand to start your presentation.
Hello, everyone. Can you hear me?
Yes, we can.
Okay. Let's start now my presentation. Okay. Assalamu alaikum warahmatullahi wabarakatuh. Dr. Samar Noor. I am working as assistant professor, Faculty of Engineering, Computer Engineering and System Department, Badr University in Cairo, BC. My paper is named AI Drive Anomaly Detection Framework for improving IoT system reliability, presented by me, Dr. Samar Noor. As a first, I will sharing my presentation. List of contexts in this presentation, introduction, contribution given by this paper, AI Drive Anomaly Detection Framework for Enhancement IoT Security, Performance Analysis, conclusion at the final. At the first, I will take about the introduction about the title of this paper, IoT improves and importance and in challenges. IoT is integrated into modern technology but faces challenges related to reliability and security, especially as the network scale and group is complex. Number two, AI for IoT reliability. AI practically anomaly detection is critical for undefined issues like system fault, cybersecurity threat, and inefficiency in IoT system. Number three, anomaly detection early detection for anomalies allow providing actions that improve system uptime, security, and operation country in IoT network. Number four, AI technology in IoT. The paper investigated supervised and unsupervised machine learning methods for real-time anomaly detection in IoT data stream. Number five, challenge in apply AI in IoT. Key challenges include drivers data, computationally requirement, processing need, and the balance between resources used and detection accuracy. Number six, anomaly detection in IoT security. AI-based anomaly detection help identify unknown security threats by detecting advising from normal behavior unlikely to security methods that rely on pre-rules. Number seven, need for centralized assessment. There is a local standard method for evaluating efficiency of model machine learning models in IoT environment, especially given the constraints of IoT devices like limiting processing power. There are some challenges in this to this paper. As the first challenge using in this paper, resources limited, consider of the device constraints in evaluation, network heterogeneous, addressing device network conditions, environment validation, testing from work with benchmark datasets, finally, a centralized practice, establish uniform evaluation method. So, contribution given by this paper. At the first, the proposal framework given comprehensive evaluations is specifically designed to assess the machine learning model for anomaly detection in IoT environments. The framework takes into consideration resources limited and network heterogeneous oscillation with IoT device. After that, the framework contributed establishing standardized practical for evaluated anomaly detection in IoT, supporting the development of secure IoT ecosystem. The proposal framework is a valid through expensive environments on benchmark dataset, providing practical utility through multiple matrices. AI drive anomaly detection framework for enhancement security. As a show is in this figure is a proposal AI drive anomaly detection framework as the first of the framework IoT devices to collect it from these devices dataset. After collected dataset, feature extraction from the dataset and the label of the dataset after that. Now we can, after collected dataset and the label app, can pre-processing data. After that, device data to port training board 20% and 20 percentage to test. After that, we can apply this data set to 6 machine learning model, training it on this machine learning model. After that, can detect any anomaly detection. More details about this framework or divided to step in this framework. The first step of this framework or proposal of the framework at the first data collection. Data is collected from IoT device connected to the internet. Step 2, feature extraction. Reveal feature or extract from the collected data to prepare it for analysis. Sure, to get features or parameter for this data. Number 3, data pre-processing. The data set ungroup pre-processing to clean and extract the data for training. Number 4, data labeling. The data is labeled as either belonging or anonymous. Number 5, data split. The pre-processing data is divided into 2 parts. First part, training part, and second part is a testing part. Modeling training. In this work, we use text machine learning algorithms, logistic regression, random forest, statistic random district, key news, my force support vector machine, and decision tree are used to build classification model. Finally, anomaly detection. The training anomaly detection model analyzes new data and categorize to either being green or anomalous red based on detected behavior. So, monitoring and analysis Internet of the Things network data is critical for maintenance of security and integration of connected systems. The following subsequent steps should be applied for accurate analysis and categorize network traffic using machine learning technology. Step 1, intercept of network traffic. Step 2, extract of features. Number 3, labeling data set. Number 4, preparing data. Number 5, splitting data set. Number 6, training of machine learning model. Finally, testing the evaluation model. In this work, work of this paper, we use real work IoT dataset. We use CIC IoT data set are used. Is provide comprehension benchmark for large scale IoT attacks, aiming to advance security analysis in real world IoT environment. We split 7 categories like DDoS, DOS, web-based, snooping, and mirroring and compression as a show this figure. This figure show or provided any indication representative of frequency of various types of cyber attacks within the analysis dataset. X-axis categorize this attack type like DDO or كذا or DOS, and while a y-axis indicated their represented frequency peaking at 14,000 instance. Performance analysis. As shown, we used performance matrices like accuracy, recall, percentage, F-score. The performance matrices for different machine learning classifiers as shown are in the result is a bad result or lowest result in RL SCDG in percentage recall F-force. After that, the result, as shown in the figure, is become more heights in KNN, SFG, and percentage recall F score. Finally, the best results comparing between six machine learning algorithms, DT or F. DT giving the highest result, and RF given the high data or the two algorithms near of the result in percentage recall enforcement. As I show in the convolution matrix to decision tree DT model convolution matrix, which also shows the model classification performance of 9 different kind of network data, including begin, interaction, and different type of attack in these maps. Finally, performance for 6 machine learning classifiers. This figure presents a comprehensive analysis variance classification model, random access, and like random access, KNA or ASA, and SDG. As shown in the figure, SVM and CHH show notably low performance for recall and F-score, indicated the struggler to accuracy and define positive instated while managed false positive. LR expect moderated performance with trade-off between recall and precision. Overall, the chart suggests RF and KNN is support model for classification task, while S support for the machine and SDG may not be stable for given dataset. Finally, of the results, this table presented comparing between the 6 machine learning classifier and the show DT getting the highest accuracy and RF, while recall has given by TT and percentage final F score. Conclusion of this paper, as shown in the figure, as a first integration of AI based anomaly detection, as a first and define for security threat identification using the decision tree or using random force, improve system performance and security, reduce downtime when stated operated of connected device. After that, feature research direction optimizes model for resources, consistent IoT device, develop propose a framework for evaluating IoT environment. Finally, conclusion of this work, enhancement system reliability, AI-based anomaly detection, scientification, improve IoT system reliability by quickly identifying and addressing fraud, secure threat, and infections. Machine learning model, the paper demonstrates the efficiency of decision tree and random force RF enhancement IoT system performance and security. Reduction of downtime, advanced methodology, help reduce downtime and ensure consistent operation of connected device in complex IoT network. Finally, research feature direction include optimized IoT model for resources for a state IoT device and creating robust framework that can be adaptive environment involving IoT environment. Thank you for attention. Any questions, please?
Thank you, Dr. Summer, for the interesting presentation. Any question from the audience? Any questions? Dr. Ismail would like to ask a question. Would you like to come here?
Okay.
Thank you for the presentation. So, I was not sure what is the.
Sorry, I can't hear you.
Okay.
Sorry.
Oh, here is the mic that makes the. Okay, you make when I use it.
Okay, hello.
Hello. Hello.
Okay, can you hear me?
Yes, I can hear you.
Okay. Okay, thank you for the presentation. So,
Thank you.
I was not sure what is the main feature that feeding machine learning. So, the accuracy and recall and F1 score it's depends on the quality of the feature. So, but in your presentation, so the detail of the feature is not explained, I think.
Okay, you want to know the feature of extract from this data?
Yes,
Like,
the
yes,
input
okay.
of the machine learning.
Okay. The feature or extract from this data like track in network any anomalous or abnormal behavior of this data. There are a lot of extract from this data. I mentioned before we used behavior data SIC data, IoT data set. So the feature of this data, as I mentioned before, like tracks of behavior of this data or network tracking and the abnormal behavior of this data, like DOS.
Okay,
You
so
can hear
maybe
me?
you have some label from the specific tool extracting feature from the network data, right?
Please again.
So I'm sure maybe you will you have used some specific tool to extract features from the captured data, right?
Yes. No. It is
Really?
already. It is already.
Already. So data set
CIC
shows
IoT
every.
data set, but this framework suggests general for anyone you want to use AI for cybersecurity. Okay. This framework is proposed in general anomaly detections.
Okay, thank you.
Okay.
Thank you very much for the question and the answer. And any other questions, please? There is one more question. Can you come closer so the Summer can hear you? So
Yes.
Summer, there is one
Yes,
more question.
I hear. Yeah, okay. Sure.
Okay, Assalamu alaikum. Thank you for the presentation. I have a question
Thank you.
about you say in the presentation that in one of the um, detecting anomalies and then addressing it. What are you specifically doing when once the anomalies are detecting? What do you mean by addressing it? Is it real time addressing?
Yes.
How is it addressed?
Yes. Okay. Anyway, AI model can automate anything for anomaly detection in cybersecurity track. So this framework, after training and tested this model, can use to using in real time. In real time, detect any anomaly detection from any environment. So it is the important mentions in AI, automated or anomaly detection. So it can use in real time. This is the answer of your question or not? Hello.
Um, do you want to follow up or you are good? She's good for now. If she has more questions, she will contact you. Thank you, Dr. Summer, very much for the interest presentation. Can we please thank the speaker? Can we please thank the speaker, please?
Okay, thank you.
Thank you very much. Our
Thank
third paper, and in the virtual session, usually we jump between tracks. So now we are moving to track 3, where is the government and policy of IoT. And our third author is Dr. Rahid Al-Kiberli from Alder University and the Ministry of Digital Development and Transport. Rahid, are you available? I can see your presentation. You can start now.
Okay, can you see my presentation?
Yes, we can.
Okay, great. Yes, thank you very much for giving this opportunity to participate here, and I'm going to start my presentation. Thank you. Of the research is about data governance with corporate strategies and considering significance of seaports in the Caspian Basin for international.
One second, we cannot hear you well. It's very low volume.
Okay, let me switch to. I just tried to make it from the recordings. Let me switch to the presentation itself. Can you hear me now?
Yes, we can hear you.
Okay, great. Oops, sorry. Okay, just a second. Okay. Just a second. Technology makes our life a little bit up. Okay. Oh. Oops. Okay, I think I can make it like this. Yeah, can you see the screen?
Yes, we can. Yes, we
Okay,
can.
great. Yeah. Yeah, thank you very much for giving this opportunity. My name is Rahid, and we are together with Dr. Robert Hausman made this research, and it's about integrating big data governance and corporate strategies in small and medium Caspian Basin seaports. Yeah, the framework which we have been focused to develop is based on the background, which we focused on significance on seaports in the Caspian Basin for international trade, as well as we focused on challenges faced by small and medium-sized ports in integrating big data for operational efficiency. The primary objective is the alignment of big data governance with corporate culture, which it's important for data stewardships in enhancing operational efficiency in seaports. And on the next slide, I want to give some inputs about the used theory, which we used resource-based view theory, and we focused on digitalization, which is important priority for today's our life. and also to be focused on resource-driven or competitive advantage. And here, primary focus was to employ current resources instead of having additional investments for employing big data in the current environment, which we have in the seaports in the Caspian Basin. And about the methodologies, we use data, which based on semi-structured interviews with key stakeholders, systematic literature reviews, and primary findings, we achieved to have strategic data alignment framework. We call it as DAF. And also we achieved the combining of the principles for big data governance with corporate strategy tailored for SME seaports. The primary question was how can stakeholders improve their understanding of integrating big data governance and corporate strategies in small and medium seaports in the Caspian Basin. And we used qualitative approach for interviews and case studies, as well as expert views, which it was important inputs to collect from the industry, I mean, from the field. And identified teams, which I want to highlight 3 of them here. It's alignment and integration, which includes importance of aligning data initiatives with corporate strategies. And stakeholders engagement was the second one, which it is actually essential for successful big data governance. And capacity building, which humans are important resource here. So human-centric approach, it's important to achieve, let's say, the most efficient alignment of the big data governance with corporate strategies as well as corporate culture. And at the result, we have two points which I want to highlight here. Strategic data alignment framework, which it has 13 key pillars, and these pillars are outcomes of our research, and this managerial framework based on these 13 pillars will be well efficient for aligning, and that also will be accelerating data culture, employing the used big data alignment framework. And also for just deep diving into the research, there are categories as well as group codes and codes, teams, as well as some codes also has been reflected in this framework. And also for employing by the managers or leaderships of the let's say seaports, which they are not well technocratic background, we developed 6-step structured strategic data alignment framework guideline, which going through these 6 steps, leaders can enhance their alignment, and it's important for using efficiency of the big data governance. So it's more institutional approach is important here. And I'm not going to go into each details for just saving you all the audience time. Just I will highlight that understanding corporate strategy also is important, and establishing governance framework, also integration of big data strategy and communication and collaboration, which on the new generation governance we have to focus on, and capacity building and training, as well as continuous improvement and adaptation is important here. About implications and recommendations, this slide, it has implications for practice as well as recommendations for seaports or employing the big data. And also, it is important to link this big data governance framework into national data governance frameworks, which is important for having competitiveness as well as sustainability in seaports linked into the overall politics of the governance practices. And about the conclusion and future research, we already highlighted in detail on the dissertation work as well as on the paper all the future research opportunities as well. But I want to highlight in this slide long-term impacts of big data integration on seaport operations, which is important, and for seaports, especially on the era of global transport projects like One Belt, One Road, as well as traditional or historical classic silkways. It is important to be linked each other, all the countries as well as transit corridor countries, and such a framework which is important for transit countries to track containers, I mean the ships, as well as transport elements as well, to make sure for example, containers are not meeting any bottlenecks in the transit countries. And also investigation of cross-disciplinary approaches for broader applicability is important, which is necessary research for the future, which it was highlighted in the research. And I want to highlight social change implications of this research, which is important to highlight that starting individual level, family level, organizational level, as well as industrial, regional, and the national level, social impact of this framework is researched, and it has important role for sustainable development, for enhanced port efficiency as well as operations as well. And it will be good for policymakers. And on the era of G5 governance, informed policymaking approach of this framework will be opening new horizons for enhancing collaborative and linked policies between transit countries as well as source and destination countries. And thank you very much. I will appreciate to all the audience for listening, and I'm open for the questions. If you have any questions, please go ahead. Thank you very much.
Dr. Rahid, it's an excellent presentation, and this topic is very, very important nowadays. And I would like to open the session for questions. Anyone would like to ask questions?
Thank you very much, sir.
Okay, with that said, can you please thank the speaker with me? Thank you very much. Our next speaker is IoT Enhanced Hybrid 5G networks for post-catastrophic assessment. And the speaker is Dr. Fatma Wahiba from France. Dr. Fatma. Thank you very much. Our next speaker is IoT Enhanced Hybrid 5G networks for post-catastrophic assessment. And the speaker is Dr. Fatma Wahiba from France.
Yeah, good morning. You hear me?
Yes, we can hear you well.
Okay, thank you. You see my screen?
Yes, we do see your screen.
Okay, so I will start. Good morning, everyone. So I'm Fatima Zahra Rabai, Innovation Program Leader at Alten, a digital services company. I'm pleased to present to you today a topic that is part of our scientific projects which focuses on 5th-generation communication intelligent IoT enhanced hybrid 5G UAV networks for post-catastrophe assessments. First of all, I will start with the presentation of company. Alten is a leading French digital company founded in 1988 by Simon Azoulay, Laurent Schwartz, and Thierry Roux. 11 Alten labs have been established both in France and internationally, offering customers innovative value propositions that combine engineering expertise and digital know-how with business services. Alten is currently present in 32 countries around the world with a workforce of more than 50,000 employees. We operate in several sectors such as naval defense, IT, banking, finance, and insurance, energy, life science, etc. In the innovation department of the Alten Group, we manage a portfolio of several programs. Currently, I am overseeing the 5G mobile program, which includes various projects. So here is the work plan. First, we will start with context, problem, objective. Next, state of the art. Then presentation of the technologies used. After that, presentation of the use case. Following this, simulation parameters and results. And finally, conclusion and future prospects. So it starts with our context. In the event of a disaster, terrestrial infrastructures are often damaged, making communication challenging. UAV or drones provide a solution by quickly establishing temporary links to coordinate relief efforts and offering real-time situational awareness through their sensors, integrating 5th-generation technology with the UAV, further enhancing this capability, enabling fast data transfers and low latency, this improving the efficiency of rescue operation. So the hybridization of 5G and UAV presents several challenges, which are how to model a hybrid 5G UAV network, how to manage the complex mobility of UAV, how to maximize the energy autonomy of drones or of UAVs. So the objective of our work is to simulate a post-disaster rescue scenario using a hybrid 5G UAV network. To achieve this, the following steps are undertaken. So first, setting up a 5G network with parameters to the use case in a simulation software, developing optimized mobility model for exploring and covering the disaster-affected area, and implementing energy management to optimize UAV autonomy. After that, so for the state of the art, several research works have focused on improving mobility for connectivity, and we have referenced these 3 papers. So the first one, it's a survey or overview about the AV-assisted 5th-generation and beyond wireless network. The second one, it's how to use the UAV to assure communication in a disaster area. And the third one, it's a proof of concept for hybrid 5G UAV network featuring a software-defined flight control system. So for the technology used, we have used many tools like Network Simulator 3, Python, Blender, and the Net Simulator. So our main steps are implementation of the 3D visualization part, implementation of the 5G UAV hybrid network, and development of mobility and energy consumption models. For our use case, so we can see that this work aims to simulate scenario where UAVs coordinate operation in a post-disaster context without actually implementing the applications operating in the control station. These applications are mentioned for demonstration purposes to highlight their potential, focusing on how the control station can coordinate operations and strategically utilize UAV data. So like K assumption, we have the environment is rectangular and obstacle free. We have also target area, target areas representing destroyed or burning houses are fixed. We have UAV. We have UAV do not include collision avoidance mechanism. We have also UAV as we have a relay UAV and we have the UAV that survey the disaster area. So we have proposed some model of displacement, some mobility model. So the first one, it's the mobility cluster random mobility, the multi-cluster random mobility. Or this mobility model organizes UAV into clusters to explore specific areas. UAVs move randomly within their zones, stopping upon detecting targets to transmit live video. This approach ensures efficient coverage and realistic movement partner. The second one, it's the multi-agent genetic algorithm mobility model. So it coordinates UAV movements by dividing them into groups. Each groups using a separate genetic algorithm instance to optimize trajectories towards specific targets. And the third one, it's a multi-cluster particle swarm optimization mobility model. So designed to optimize the trajectories of UAV organized into clusters. Each cluster operates within a designated area, and UAV acts as particles in a particle swarm optimization framework. They iteratively adjust their positions and velocities based on personnel best, cluster weights best, and inertia. The model enhances coordination by focusing on cluster level optimization rather than a global solution, enabling efficient target search and load distribution. The key parameters include, so we have a particle, we have our particles and we have some coefficient like for example, the C1 influence of the UAV's personnel best position, the C2 influence of the cluster's best position, and the inertia coefficient, and balancing exploration and exploration. So after that, this is a presentation of the solution proposed. This is the figures. The figure shows a 3D visualization of the disaster area with fleet of the drone hovering above. So we have taken it with net simulator. After that, for the simulation parameters, so the table presents the simulation parameter considered, such as we have taken consideration the area of simulation, time of simulation, UAV. We have divided the UAV into types, UAV relays and the UAV for research, etc. And for the results, so we have taken three parameters of quality of service. So it's throughput, end-to-end delay, and the packet loss. The first parameter is throughput. So the analysis of the graph in the first figure 10 highlights trends regarding the developed mobility models, particularly the multi-cluster PSO, multi-agent genetic algorithm, and the multi-cluster random models. These models demonstrate superior performance compared to the other classical, conventional model like paparazzi and Gauss Markov, and show a convergence towards stable throughput over time. This can be attributed to their approach based on the use of cluster. So we pass to the second one, the figure 11. So it represents the comparative analysis of end-to-end delay. MCPSO, Imagea, and MC Random show improved results compared to the other models. In models that do not use clustering, like paparazzi and ghost Markov, there are maybe handovers because the movement of UAV is unpredictable. These handovers involve a UAV disconnecting from its relay UAV and switching to another. These handovers can introduce delays. Additionally, in the context of the project, latency can influence it by the distance between UAV and their associated relays. So the three mobility model that utilize clusters exhibit better delay performance compared to paparazzi and Gauss Markov. This aligned with the rationale behind the throughput performance justification. After that, for packet loss, figure 12 illustrates the packet loss rate, showing that the MCPSO model performs best by minimizing interference through optimal relay UAV positioning, resulting in the lowest packet loss rate. The multi-agent genetic algorithm, while slightly less effective, still outperforms MC Random, which has the highest packets loss due to its random nature. The paparazzi and Gauss Markov models rank lowest, lacking intelligence mechanism for movement, which complicates the relay UAV's mission for coverage. Clustering-based model like MC Random, MCPSU, Imagea, provide clear advantage in network performance, particularly in our use case, by facilitating communication management and optimizing throughput, delay, and packet loss rates. And for conclusion and further prospects, so we can say that this work explored the hybridization of UAV with 5G technology in a post-disaster context. It demonstrates how a 5G UAV is hybrid network can enhance communication and revolution environment monitoring and data collection. The study incorporated diverse mobility models to evaluate UAV's performance in post-disaster scenarios. Mobility model ranging from random dispersion to cluster coordination and trajectory optimization show UAV mobility impacts network performance. And as future work, so we work now or we aim to incorporate different reinforcement learning models for UAV positioning, like deep Q-learning. We use also policy, PPU, actor I2C, actor critic for research and rescue. So thank you for your attention, and don't hesitate if you have any question. Thank you. I don't know if you have any question. You hear me? You have any questions?
Can you hear me, Dr. Fatma? Can you hear me?
Yeah.
So I'm just thanking you for the presentation. It's very interesting. And I was telling you that one of the famous applications that we have in the US is finding a lost person or a lost kid in the forest and using machine learning to try as fast as possible to find the person using drones. So this is a very important topic as well. So we might want to consider this type of applications as well. I want to ask the audience any questions? Any
Thank you.
questions? Dr. Ismail has a question. So Dr. Fatma, stay with me.
Yeah.
Okay, thank you for the presentation. So
You're welcome.
yeah, so when I saw your slides, so I feel that transmission rate of the video streaming is relatively high. So it was 32 megabps, right? Is that right?
Can you repeat, please, your questions?
So
You
I'm
want
just
to send a video with a big volume?
yeah, okay. So maybe you in the simulation you set the video streaming rate
Yeah.
as
And we used 5G. So, for example, here we have used drones for outdoor environment, and in my company we have drones for indoor environment, and we have provide 5G. So when we test, we can have um, uh, throughput. It the best 2-3 gigabytes. So we can send a video. I don't know if it's clear or no.
it's okay. So I just wondering. So for setting the higher bandwidth makes the loss rate higher. So I think at the end of the slide you show the very high packet loss rate graph. So I would decrease the video rate to improve the packet loss rate. So do you have any data to show the trade-off between the bandwidth and packet loss rate?
I don't listen very well, and there is some coupure, so I don't know. I don't know what you mean.
Okay, so I will read your paper and send email if I'm not sure about that. Okay, thank you.
Okay, you're welcome.
Thank you, Dr. Ismail, for the question. I just want to clarify the question. He's wondering if you were able to lower the quality of the video and see how the effect on the packet loss will happen. So that would be a good idea to explore as well. With that said, we would like to thank the speaker. Please join me in thanking Dr. Fatma. Let's thank her, the speaker, one more time. Thank you, Dr. Fatma. And now we are moving to the next
You're
paper.
welcome.
And now we're moving to our next paper, Dr. Pouya Gazizada. Dr. Pouya Gazizada from St. Johnson University in USA. And the title of the paper is The Impact of Redundancy on Resource Utilization in Vehicular Cloud. With that said,
Hi, Dr. Sami. Can you hear me?
We can hear you well.
Okay, let me share my screen. Hello, everybody. I am Pouya Gazizadeh, Assistant Professor of Computer Science at St. John's University. I'm going to present a collaborative paper authored by Omar Nareen, Aida Gazizadeh, and myself. The title of our paper is The Impact of Redundancy on Resource Utilization in Vehicular Clouds. Building upon the success of conventional cloud computing, the concept of vehicular clouds was introduced. Vehicular clouds rely on groups of vehicles whose corporate computing, sensing, communication, and physical resources can be coordinated and dynamically allocated to authorized users. Vehicular clouds differ from conventional cloud computing by employing untapped resources with distributed ownership. In a vehicular cloud, nodes are not available consistently due to random arrival and departure of vehicles. This creates a variable operating environment in which effectively assigning and completing assigned jobs become difficult. Over the past decade, information technology has revolutionized the society. Cloud computing has been a central component of the information technology. Cloud computing has enhanced the accessibility and affordability of computing for businesses of various scales. The rapid growth of cloud computing over the past decade has been fueled by its flexibility, scalability, and ease of use, leading to widespread adoption and integration. Um, Modern vehicles on the road are equipped with GPS systems, radio transceivers, onboard computer, camera, radar for collision prevention. These features can be considered baseline, with higher-end vehicles offering additional capabilities such as multiple cameras, more specialized processors, and enhanced sensing equipment to support advanced safety systems and onboard information systems. Newer, more advanced vehicles offer access to significant processing power, particularly when operated collaboratively. The computing power of these vehicles, which can be many times faster than most modern consoles, phones, even desktop computers, often remains underutilized while they are parked. According to estimates, the average modern car has between 1400 and 1500 semiconductor chips. Some cars can have as many as 3000 chips. That's a lot of chips. You could say that modern cars are like giant computers on wheels. With over 800 vehicles per 1,000 people in the US, there is a significant opportunity to utilize many of these vehicles as computation nodes within the vehicular cloud. Incentives can facilitate a broader adoption of vehicular cloud systems. Potential implementations of such a cloud could include long-term airport parking lots and university campus parking areas. The distributed ownership and the unpredictable arrival and departure of vehicles in vehicular clouds lower the probability of job completion. The primary challenge in this assigning jobs to a vehicle is the unpredictable nature of nodes' presence at its location and its commitment to the vehicular cloud. In order to enhance the probability of job completion, we propose redundant job assignments that can be implemented at three different levels. If a vehicle leaves before completing its assigned job in a non-redundant system, the job would need to be reassigned to the next available vehicle. This would result in a significant loss of computational power and delay in completing the task. Redundancy provides an additional layer of protection against these complications. Redundant jobs assignments can be applied at three levels. At each hierarchical level, from lowest to highest, an additional vehicle is allowed per job, adding an extra layer of redundant computing power. This approach to redundancy significantly improves job completion rates, which uh, each additional node per job, but it also leads to less efficient use of resources. Here I'm going to talk about the simulation model. So in our model, jobs are submitted by users to the cloud controller. These submitted jobs are stored in a queue and processed in a first come first served order. And we assume that we are simulating a vehicular cloud established in airport parking lot, and the capacity of the parking lot is 500 spots. In our simulation, we monitor the parking lot for 24 hours in order to determine the resource utilization for the proposed algorithms. We assume that vehicles arrive in parking lots with varying residency times. The average residency time for vehicles ranges from 1 to 24 hours, with residency times uniformly distributed within this range. We assume that the number of jobs submitted is sufficiently large to ensure that there are always jobs available to be assigned to vehicles throughout the 24-hour period. The average duration time for a job ranges from 1 hour to 3 hours, with job duration uniformly distributed. I'm going to present our simulation results next. So we have developed a simulation using Java, and we have created 9 comprehensive set of scenarios. Because of time limitation, we cannot go through all these scenarios, so I picked 2 scenarios and I'm going to discuss the results for those scenarios. But first, let's review the parameters for different scenarios that we have. So in scenario 1, basically we have examined a vehicular cloud operating with the algorithm L1R. The job duration ranges from 0.5 to 1.5 hours, with an average duration of 1 hour using a uniform distribution. The second scenario is for the same algorithm, L1R. In this set of scenarios, we examined the vehicular cloud and used L1 algorithm again. The job duration ranges from 1 to 3 hours, with average duration of 2 hours, using uniform distribution. And finally, the last scenario for L1R algorithm is where we basically use jobs that have durations ranged from 1 to 5 hours, and the average duration is 3 hours, and we have used uniform distribution. Now, for scenarios 4, 5, and 6, basically we have examined the second algorithm, which is L2R, and the level of redundancy here is 2, which means we assigned one job to 2 vehicles at the same time, but the parameters are the same. So the parameters that I reviewed for scenario 1, 2, and 3 are same for scenarios 4, 5, and 6. And finally, the last 3 scenarios are for the third algorithm, which is L3R, and the level of redundancy here is 3, which means we assign 3 vehicles to 1 job at a time. But again, the parameters are same as 1, 2, 3 in terms of job duration and average job duration. So I'm gonna review the results for the scenario 1. Using our simulation, we obtained more comprehension of resource utilization of the 3 algorithms proposed in our work. The results that you see here in figure 1 show that if the vehicle's redundancy time exceeds 10 hours, then the number of completed jobs does not change drastically. This indicates that longer residency time beyond 10 hours do not enhance resource utilization for jobs with short duration. Another observation from the results in figure 1 indicates that the inflection point occurs at an average residency of 5 hours. This insight suggests that establishing a vehicular cloud on campuses or in locations where people work for 5 hours at least, with an average job duration of 1 hour, is a great choice. And the final set of results that I'm gonna present today is from scenario 1. For all the results, you can refer to the paper. So let me review the results here. The results presented in this figure basically confirm that increasing the level of redundancy raises the inflection point. In other words, as redundancy levels increase, the average redundancy time of vehicles must also increase to enhance resource utilization in the vehicular cloud. Analyzing the results show that the third algorithm, which is L3R, in this algorithm, the reduction in resource utilization is greater than expected when we compare it with algorithm L1R and L2R. Here I'm gonna basically present the conclusion. So in this work we have presented 3 different algorithms, L1R, L2R, and L3R. And the first one we assign 1 vehicle to 1 job at a time. In the second one we assign 2 vehicles to 1 job at a time. And finally, in the last one, the third algorithm, we assign 3 vehicles to 1 job at a time. In this work, we have analyzed the impact of redundancy on resource utilization. We have identified different inflection points for the proposed L1R, L2R, and L3R algorithms across various scenarios. Our simulation results indicate that having an average residency time longer than the inflection point becomes increasingly important for improving resource utilization, especially as job durations increase. We have also demonstrated that extending residency time beyond certain hours does not improve resource utilization for short duration jobs. These thresholds vary depending on the specific scenario. Finally, analyzing the results reveals that in the redundancy-based algorithms, L2R and L3R, the reduction in resource utilization is greater than anticipated compared to the non-redundancy algorithm L1R. This was our conclusion. Thank you for taking time to attend this presentation. At this point, I'll be happy to answer your questions.
Thank you, Dr. Buya Gazizada, for the presentation. Interesting topic, and would like to open the floor for questions. I have a question for you. Maybe it's time to include. So the idea is you would like to know which car to assign the job as a redundancy to, and adding a little bit of machine learning of features of the car may allow you to pick the redundancy in a better way. So if I know that car X always stay from 8 to 8 p.m. in the parking garage or in the parking lot, I will give it a weight that's much higher for a longer assigned jobs. And by doing this, machine learning might help you in improving the redundancy by selecting the cars that we know that will stay for a certain time very close to the job that we are trying to finish. I'm just suggesting adding machine learning to the feature and see how the performance will be compared to other algorithms.
Yes, thank you, Dr. Sami. This is a great insight. In fact, we are starting a new research based on what you mentioned, because we have realized AI has been very popular recently, and machine learning definitely will help our project. So you are absolutely correct, and this probably will be our next research that you are going to work on.
Excellent. Any questions from the floor? Okay, let's thank the speaker, please. Help me thank the speaker. Thank you very much.
Very much.
And our next paper is Enhanced IoT Security Through federated learning approach. And the paper and the author is Dr. Aisha Tabasim from Indiana University, Bloomington, USA. Dr. Aisha, are you here? Okay, so we are going to move to the next paper, our last paper for the session today. We have Dr. Nadine Faris from York University in Canada, and the paper title is Decoding Justice, the Synthetic of AI and Machine Learning in the Legal Landscape. Dr. Nadine, are you here?
Yes, I'm here. Just give me 1 second
Take your time.
as
Take your time.
I connect my
Take your time.
Sure. Okay. See my screen?
Yes, we can.
Okay, perfect. Okay. Good morning, everyone, and good morning from Canada, but good afternoon for everyone who's in UAE. Before I begin, I'd like to take a moment to appreciate the insightful presentations we've heard today. The depth of the work presented highlights the incredible steps we're taking towards our respective fields, and it's truly inspiring. So thank you for that. And so I want you to imagine a world where law enforcement agencies can anticipate crimes before they occur, allocate resources more effectively, and make communities safer, all by harnessing the power of advanced technologies like artificial intelligence, machine learning, and the Internet of Things. These transformative tools are rapidly shaping industries worldwide, and law enforcement is no exception. So, for that, today, we'll be exploring how these technologies can revolutionize, change crime prevention, while also addressing critical ethical and operational challenges, paving the way for a safer and more equitable innovation. And for that, I'll be presenting our work titled Decoding Justice, the Synergy of Artificial Intelligence and Machine Learning in the Legal Landscape. Integrating advanced technologies can be very promising when done for a human-centered benefit. The use of AI, machine learning, and IoT is progressing rapidly among most industries. As you know, AI enables a machine to mimic human intelligence for tasks like decision-making, pattern recognition, and predictive analysis. Machine learning, a subset of AI, that allows systems to learn from data and improve over time, can be used in law enforcement for predicting crime trends and patterns. And IoT connects devices to share in real time, enhancing surveillance, resource monitoring, and situational awareness. Consequently, law enforcement agencies can utilize these technologies to proactively prevent crime, optimize resource allocation, and improve operational efficiency. You might think that merging AI and law would only benefit law, but in fact, the nature of the relationship between these two domains is a mutually beneficial one. It's true that AI with ML and IoT can identify patterns and promote proactive law enforcement measures, but also the legal endorsement of AI enhances public trust in AI and promotes further innovative projects. And for that, our research objectives lie within 4 main points. Proactive crime prevention and data utilization description. We demonstrate how AI and ML qualitatively can enable law enforcement to transition from reactive to proactive approaches. We talk about innovative AI technologies and how the use of tools like facial recognition to improve surveillance can enable adoption of advanced technology. We discuss ethical framework development as we advocate for a balance between AI benefits and privacy protection through responsible technology use. And finally, we contribute to driving research forward as we expand the scope of academic and practical research to explore new AI applications in law enforcement while addressing the technical, legal, and ethical challenges in this evolving field. Research in this area has been growing recently and rapidly, and the common insights are leveraging AI and ML for innovation and law can enhance enforcement. However, there seems to be a need of ethical considerations and transparency in AI deployment, and improving societal welfare and justice through AI should remain the goal. A study by Chesterman and others finds that the integration of AI in legal practices presents a dilemma, suggesting a utilitarian view of law. And the implications of this is that it raises ethical concerns about treating individuals as tools, potentially undermining their inherent worth. Another study by Shah and others finds that policymakers must develop effective preventive measures to address increasing criminal activities. And the implications of this is that it emphasizes the need for strategic policing and the adoption of AI-driven tools to stay ahead of evolving criminal trends. And finally, a research study by the Kalbab and others finds that criminal record analysis can reveal insights into social structures of communities. And this provides decision makers and governments with targeted information to address issues related to specific demographics, improving tailored crime prevention strategies. Different types of AI and machine learning approaches exist, and they enable different uses and functionalities within law enforcement and policies. To go further into details, we have machine vision, I'm sorry. It uses AI to analyze and interpret visual data for object detection and classification. Common applications include facial recognition, fingerprint matching, and ALPR, automatic license plate recognition, just like we see in the image. We have predictive analytics, enhances predictive policing through place-made or individual-based, crime hotspot, or identifying individuals at risk models. An example includes crime hotspot mapping tools like PredPol, and we're going to talk about that in a bit. We also have natural language processing, which improves reporting and accuracy efficiency by enabling real-time transcription, translation, and voice-to-text dictation. And this expedites report generation and reduces error. As long as autonomous robotics, where they help with surveillance, behavior detection, and operations in high-risk areas where it wouldn't be safe for a human to operate. An example for this is the Nightscope K5. And the computer-aided dispatch is another functionality where AI integrated systems like rapid deploy can help in resource allocation, cost savings, and automated workflows. It's worth noting that the AI advancements market in law enforcement is projected to exceed $5.7 billion this year, with numerous new use cases expected. As we have an idea on the functionalities that lie within AI and law enforcement, now we're going to have an idea of where those functionalities are taking place around the world. So, for example, in the UK, the London Met Police utilized live facial recognition, LFR, for public safety. In Singapore, the police force deploys patrol robotic police that assist in incidents. In UAE, Dubai police uses automated traffic accident report generation and streamlines law enforcement services. In China, authorities employ extensive surveillance to predict crimes and protests, and in the US, specifically Los Angeles, the police force plans to use machine learning to improve officer training and public interaction accountability. Implementing AI in law holds multiple benefits and risks for the legal domain. But while it can enhance efficiency and operational optimization through uncovering social networks and identifying patterns, risks include data misuse and breach through cyber attacks, and mishaps and liability concerns through false accusations. Moreover, when it comes to bias, we can see that AI implementation in law is a double-edged sword, where there are both risks and benefits regarding bias. While bias can be detected through pattern identification and then halted or stopped, it can also be exacerbated along with other discriminatory stereotypes and factors. For instance, in 2020, Robert Williams, an innocent civilian, was wrongfully accused and convicted of a crime due to false facial recognition. Also, researchers found that Pretpol, the crime hotspot mapping tool that we were talking about earlier, may be creating was found to be creating a feedback loop, causing officers to patrol specific neighborhoods other than those with high racial minority populations, regardless of the actual crime rates in those areas, suggesting a form of bias. Consequently, it's paramount for AI and machine learning developers to ensure accuracy, lack of bias, and precision in their designs. This responsibility aligns with that of legal authorities who might stay abreast of advanced technology trends, learn effective governance, and integrate these technologies into safety and crime prevention practices for the greater good. And to accomplish this successful tech law vision, we recommend the following suggestions. First, we need to focus on enhancing comprehension and transparency. So, people from the legal domain who don't have a technical background can use explainable AI to clarify AI decision making processes and outcomes, fostering reasoning and transparency. And on the other hand, people from from the technical domain can leverage resources like the Legal Information Institute to improve understanding of legal concepts and terminology. We also need to establish clear regulatory measures where we need to adhere to AI governance frameworks like the NIST, PDPC, AIDA, or develop new ones. And we need to ensure alignment with international human rights and ethical guidelines. Another recommendation is to maintain a human in the loop system where we preserve accountability by involving humans in critical decision making stages and emphasize algorithmic auditing, testing, and supervision to mitigate unforeseen risks. We also need to work on promoting fairness and equity, and for that, we can use technology itself. And I like to call this regulation of technology by technology, where we utilize tools like Google's fairness indicators, IBM's AI Fairness 360 to evaluate and mitigate AI model biases. And we can also approach AI models as tools rather than ultimate investigators, limiting reliance on potentially flawed predictions. Moreover, we need to foster multi stakeholder collaboration as we encourage partnerships among law enforcement, academia, civil society, and technology experts to develop ethical and effective practices. A successful example of this is being done in the US. It's called the US Police Data Initiative, and it works on enhancing transparency through data driven strategies. And finally, we need to address social and ethical challenges by promoting ongoing debates and discussions led by ethicists to clarify existing ambiguities and prepare for future challenges in AI advancements. With these recommendations in mind, it's essential to reflect on the broader implications and the transformative potential of integrating advanced technologies into law enforcement practices. And with that, we conclude with the following 4 points. One, human focused innovation. We need to understand that integrating AI and machine learning into legal systems addresses societal issues while reinforcing the positive, trustworthy role of technology in community welfare if done correctly. Proactive adoption by law enforcement agencies. This demonstrates how advanced technologies can enhance operational capabilities and contribute to a safer, more equitable society. Comprehensive exploration. This research explores the dual nature of AI and law, offering practical recommendations and advocating for transparent, ethical integration. And finally, broader impact. The insights provided in this research hopefully serve as a blueprint for other industries, guiding them in navigating AI's inevitable growth while ensuring ethical and equitable adoption. Thank you very much for listening, and I'm open to questions.
Dr. Nadine, thank you very much. This is a very important topic, and a lot of people are actually scared from the use of machine learning and AI in the new world application. So I really think your topic is a very important topic that we need to address in most of the new applications that we have. With that said, I would like to open the floor for questions. Any questions? Let's thank the speaker. Please join me to thank the speaker. Thank you very much.
Thank you very much.
Thank you, Dr. Nadine. And this concludes our virtual session. Tomorrow, we have in the morning our official opening. And thank you very much. Enjoy the welcome reception. Thank you very much. Have a wonderful day.